Hello guys, Mrs. Tolle here from your tutors. So today we're going to look into we are still on finance, but now it's lesson 3 and we are looking at different compounding periods. I think you guys have seen in some cases you see that interest rate is maybe 15% per annum, compounding monthly, or 15% per annum compounding weekly. We are going to be dealing with that and see how do we deal with such situations. Okay, now let's get into it and see how far we can go today. You know I like to start with questions. Try those questions. See if you are getting the answers displayed there. If you are not getting the answers, let's dig in together here. Now, what we see here is that when I talk about different compounding periods, we are saying we are used to say maybe it's 5%. Let's give an example. Let's give an example here. It's 5%. Oh, sorry about that. So it's 5. Let's say it's 5%. Let's say it's 5% per annum compounded annually. So in that case there, it remains as 5%. But now, if we are going to have same annually, it means that that interest is calculated twice a year. Twice a year. So same annual is 2 times. So if it's 2 times, we are saying here, if it's 5%, what we call per annum. So if it's 5% per annum compounded same annually, it means that here we're going to say, okay, the 5%, it's 5% over 2. So it's twice a year. So in most cases, you see that it's going to be 0.05 over 2. But when you are having, quarterly, it means that it's charged per annum and it's compounding 4 times, because it's quarterly. So it's 4 times here. So if it's 5% per annum compounded quarterly, it means that it's 4 times, which is 5% over 4, which is going to be equal 0.05 over 4. That's how we write it. What about if it's monthly? It means that how many months in a year? It's 12 times. So it's 12 months. So it's 12 times a year. And that 12 times means that if it's 5% per annum compounded monthly, this means that it's 5% over 12, which is going to be 0.05 over 12. And I think in some cases, you can see a percentage written like this, 5 over 400, or 5 over 1200, or 5 here over 200. That's what it means here when you are having something like that. Okay, still the same thing. Still the same thing. You can put it in whichever way. But now let's look at if it is weekly. How many weeks in a year? 52. So it's 52 times. So if it's 5% per annum compounded weekly, it means that it's 5% over 52. Which is going to be equal 0.05 over 52, which you can also say it's it's 5 over 5200, like that. What about if it's daily? Daily is 365 times. So it's like if it's 5% per annum compounded daily, it means that it's 5% over 365, which is going to be equal 0.05 over 365, which you can also put it as what you call 5 over 36500. Okay, now because we know that here it's just going to be 5% over 1, which is just 5%. And if you want to put it as a percentage, as over 100, it's going to be 5 over 100. Okay, now that we have got the 2 here, it's going to be 200. We also have the what you call the 4 there, then it's going to be 500. Okay. Okay. So then now let's see if we can attempt some questions here. Pauline invests 35,000. Calculate the future value of your investment in 6 years' time if the interest rate is 17% per annum compounded what called annually. That's the first time. That's the first one. So if it's compounded annually, what do we know, guys? We know that it's gonna be. We know that we are using A is equals to P 1 plus our I to the power of n. And in this case here, our I is just, no, let's not put our I there. Let's put the time. Time is n. It's what is it? What is it? It's gonna be here. It's gonna be 6. Let's not put this because it's gonna change, man. It's gonna change. Let's now see how it changes. Now, for example, here in the first one, our A, our P is 35,000. So our P does not change here. It's just 35,000. We don't need to repeat it again. Our I in this case is just what? 17%. So if it's 17%, 0.17, I want to put it in this way. 17 of 100 is 0.17. So if it's 0.17, let's calculate our A. Our A is going to be equals to 35,000 in bracket 1 plus 0.17 to the power of 6, because 6 years. So n here is going to be equal to 6. Okay. Now, so we can calculate that. Now, let's see here when you're dealing with your half yearly. Half yearly here, we see that our I in this case is going to be, because remember it's 2 times a year, so it's going to be 0.17 over 2. What about our n? Our n is, remember, it's 2 times a year, so it's going to be 2 times 6. So it's going to be 2 times 6, which is going to give us 12. So in this case here, our A is going to be P is 35,000 in bracket 1 plus, what is our I? 0.17 over 2 to the power of 12. Okay. That's what we do here to get our answer. Let's see the last part here. It's quarterly. So our I in this case, it's 0.17 over 4. What about our n? Our n is going to be equals to 4 because it's 4 times a year times what called number of years is going to be 6. So it's going to be equals to 24. So it's 24 times. So how do we get our A here? A is going to be equals to 35,000 in bracket 1 plus 0.17 over 4 to the power of 24. Okay, now then we can get our answer there. Let's do the calculations there. Let's do the calculations. Now let's see here, if we put monthly, we know that our I in this case is going to be equal to 0.17 over 12, because it's 12 times a year. What about our n? Our n is 12 times 6, because it's 12 times a year. So 12 times 6. Let's see what we get there. If we say 12 times 6, 12 times 6, we get 72. So it's 72. So it means that when you're calculating amount, it's going to be A is going to be equals to 35,000. 1 plus 0.17 over 12 to the power of 72. Okay, what about weekly? Let's see with weekly there. Our I is going to be equal to 0.17 over 52 times. Remember, 52 weeks in a year. And that what is our n? Our n is going to be equal to 52 times 6. Let's see what we get to that. 52 times 6, we get 312. So it's going to be 312 times. It's going to compound. It's going to be compounded 312. So A is going to be equals to 35,000 in bracket 1 plus 0.17 over 52 to the power of 312. 12. Okay, now let's see the last part there, which is for our daily. The daily here, I is going to be equal 0.17 over 365. And when you've got 365, remember how to get n. N is going to be equals to 365 times 12. And what is 365 times 12? Let's see here. 365 times 12. What do we get? 4,380. 4,380. That becomes our n. So it means that when calculating accumulated amount, it's going to be 35,000. In bracket 1 plus 0.17 over 365 to the power of 4,380. Now let's punch and get the values there. So can we see what we are seeing here? Can we see the trend in this case here? So you can see that when you increase compounding periods a year, you are also going to increase the accumulated amount. It's going to accumulate to a bigger value. So the value increases. So you can see that from annually, once a year, interest is going to give, the accumulated amount is going to come as 89,000, the investment. Now, but when you invest and it's half yearly, it's what called the interest is, it's compounding half yearly, it means that you're going to get 93,000, which is a bit higher than 89. Then when you increase to 4 times a year, you find that you are getting 95,000. It's also increasing. You can see that. Then monthly, you can see how the increase is. And there isn't much difference between your monthly and weekly there. But when you see that a big jump there from your weekly to your what called your daily, because now we are doing it daily, and again you see the amount that you are getting there is 269,000 what called and 43. That's what you get. So when you increase the number of compounding periods, you're also going to increase accumulated amount. Okay, let's go on to the next our next slide there. Now what we have here is that there is an investment here. 360,000 is invested for 6 years at an interest rate of 13% per annum, compounded quarterly. Thereafter, the accumulated amount is reinvested for further 5 years at an interest rate of 18% per annum, compounded semi-annually. Calculate the value of the investment at the end of the 11-year period. Now, I think we've done this in our previous lecture. We now know what we do. We split this. So how do we split? We have our timeline. So our T0, we have got how much here invested? 360,000. And after how many years? Let me just see here. For 6 years, okay. So 6 years there. So you can say T6, and there is T what call 11. So after the first 6 years here, we are seeing that the percentage here is what call I is 0.13, and remember it's compounded quarterly, so it's quarter over 4. Then what about for the last 5 years? We are saying our I there is equal to 0.18 over, it's compounded same annually, it's over 2. Okay, then what about our N in this case here? Let's see the N. N is going to be equals to how many times a year? It's 4 times. So it's going to be 4 times done times, what is it? What do we have here? We've got how many years here? It's for the first 6 years times 6, which is going to give us 24 times. So our N is 24. What about our N in this case here? Our N is for the remaining 5 years here. And how many times a year is 2 times? It's going to be 2 times what call 5, which is going to give us 10. So you can now see that the N there is changing. So it's good that you calculate your N, you also write down your I before you do any calculations. Okay. Now, what else do we know? That we know that here, when we are having P, our P in this case is going to be equals accumulated amount for the first 6 years. That's what we know. That's our P after the 6 years. Now let's do it. I think you now understand my method here. So for the first 6 years, we're going to say A6 is going to be equals to, remember we're using the formula for compound, is going to E is equals to P 1 plus I to the power of N. Now, here we have got A 6 is going to be equals to our 360,000. That's our P 1 plus, what is our I in this case is 0.13 over 4, okay, to the power of what? What is the power A? Power N, which is 24. Then now what do we get from there? Let's see what we get there. We're going to say 360,000. Just going to try to be quick here. 1 plus 0.13 over 4. Okay, we have that to the power of 24. Let's see what we get here. It's going to be 775,646. So 775,646, which is 70 there. Okay, so that's what we get there after that. So what I want you also to teach you is that you can store your values. You can store your values. You press Shift, store A, then you know that your value is saved there in A, because you don't need to round off before you reach the final answer. Okay, get used to that. Otherwise, you get wrong answers. Now, let's also get to see the accumulated amount after 11 years. A11 is going to be equals to our 775,646,70 in bracket 1 plus, what is our new interest now is 0.18 over 2 to the power of what? To the power of 10. Let's see what we get that. What we get when we do that. So I just want to clear this and I want to show you what you do. Now you want to retrieve your A, you just say recall A. Recall A, you have your answer now. Then you say, okay, let's have our formula there. Recall A times, we have got in bracket there 1 plus 0.18 over 2. What do we get there? To the power of 10. Then we can just say, you can say Shift store B. So this is how you do. It's 1,836,000. It's 1,836,000. What else is there? 237. So it's 237, 237, 82. So that's our value there. That's our final answer. So I hope you guys understand how it's done, how you calculate when they are changing in the interest. And remember also, check with interest what the compounding periods is. It matters most because it affects your N. So compounding periods affects your N, then also affects your I. So it's something that you need to remember, you mustn't forget. Okay, so thank you guys, until next time, bye bye.